Welcome to Unit 1, Lesson 13. This is Part 2. We've done most of this lesson already in Part 1 video. This is Part 2. And we tried to finish it all and ended up just short. So we really have just these last 4 problems, A, B, C, and D, of example 3. So let's get going on them. If there's anything you do not understand, please refer back to Unit 1, Lesson 13, Part 1. All right, let's get started, shall we? Does this all what it does? Look at that. Everything's together. Solve each of the following quadratic inequalities. Write your answers in interval notation. Okay, what that means is you're going to put your answers in parentheses, brackets, maybe a parenthesis with a bracket or vice versa. Okay, that's interval notation. We have to write our answer like this. Okay, and the second request they're making is that they want us to represent the solution set on a number line. Easy enough. We've done that already in part 1. So let's get going here. I am going to solve this quadratic as though it was an equal sign here to get 2 points on my number line. So what multiplies to negative 36? That adds to negative 5. Okay, this is the product sum method. And I would say that is 9 and 4. Negative 9 and positive 4. And if I T-bone that, I get x equals 9 and x equals negative 4. Now these two numbers become the two numbers or points on my number line. Here's my number line. Here's negative 4. Here's 9. Okay, I'm going to put 2 circles here. Now the $1,000,000 question is, do I fill them in or are they empty? If there is a straight line underneath my inequality sign, meaning less than or equal to, greater than or equal to. If I have a straight line, that means I fill in the dots. Okay? If the line was not there, if those lines were not there, then I would not fill in the dots. I would have an empty circle there. Okay? The line underneath just means it includes the numbers. And we want to include negative 4 and 9 in our answer. Now we got to see, is my solution set going to be in between these 2 filled in dots? Are they going to be on the outsides of these 2 dots or whatever? And the way we like to do that is we like to pick a number and test it. And I always, 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 if available, like to pick 0 because 0 makes things go away. So all I'm going to do is I'm going to put a 0 in for my x's. Okay? And I'm going to see if this inequality is true or not. If the inequality works with zeros in for those x's, then 0 is in the solution set. If I plug a 0 in for those x's and the inequality does not work, then 0 can't possibly be in the solution set. All right? So let's do that. Let's take green, and we have x, which is 0 squared, minus 5 times x, which is 0, minus 36 is less than or equal to 0. Well, these go to 0. Negative 36, is that less than or equal to 0? Yes. So do I want 0 in my solution? Yes. So my solution is going to be in between them. Okay, like that. So that's the number line part. But they also want us, okay, highlighter, love this highlighter. They also want us to write our answers in interval notation. So I'm going to do that right now. Okay, well, I'm going to go from negative 4 to 9. Okay, but do I use my parenthesis? Do I use my square bracket? Do I use one of each? How do I know which one to use? Again, I'm going to look at my sign. If my inequality sign has the straight lines underneath it, then you want the straight lines in your interval notation, meaning straight line, boom. Okay, so this has the straight line underneath it. So I want to use the straight lines here. Okay, a filled in circle will always have these squared brackets because it includes the numbers. If I did not have these straight lines here, that's when I would use my parentheses. Okay, and you could have one of each. That's fine. You can have a parenthesis and a bracket, but in this case, we don't. All right, so really, when they're looking for my answer, they're asking me for two things. Here is the number line and the interval notation right there. If you want to pause this and do B, C, and D, go ahead, because I'm about to do them right now. Okay? Let's take a look at B. I'm going to do this in the same manner. Okay? I am going to factor my quadratic just as if it was an equal sign instead of an inequality sign. And I'm going to get my two values to put on my number line. Okay? So, well, I like to have whatever my x squared is be positive. So I'm going to factor out a -1 from all these terms. So it's going to flip the sign. So I have a positive 2x squared plus 7x minus 3. And I'm going to say equals 0 because, again, I'm going to solve it like it's an equal sign. Slip and slide time. If you want to use M factoring, you can. Factoring never goes away, okay? So I'm going to slip the 2 and multiply it to the back. So this -1 just comes for the ride. I now have x squared plus 7. Yeah, you know what? That's a boo-boo. Wow. Holy smokes. I flipped the sign. I flipped the sign for my first one. But if you notice, I didn't flip the sign for these two. That would have been a major boo-boo. 7x plus 3. Woo! Glad I caught that there. So, you know what? If some of you guys were watching this and you started to do it on your own, and then you started to play this, you would have been like, oh, no, I did something wrong. What happened? No, every once in a while, when you do a million math problems and your mind turns to mush, it's easy to make a mistake. But a level of intelligence, and this goes for everybody, is if you can catch that mistake. All right? So there's no shame in making mistakes. It's awesome if you catch them. It would have stunk if I would have made this video and not caught that. All right? So here we go. We are still slipping the 2 out back, and now we have minus 7x plus 6 equals 0. Booty cheek and T-bone. My -1 comes for the ride. I need two numbers that multiply to 6 that add to -7. To me, that's very simple. It's -6 and -1. Everybody always forgets about 1 times the number. Everybody's always like 2 times 3, it doesn't work. No, there's always 1 times the number, and that's exactly where you start. All right? Well, I slipped the 2 out with multiplication in the back. So now I'm going to bring the 2 back in by dividing the backs. Still have my -1. This produces the x minus 3. This will stay, well, I can't reduce 1/2, so I bring that up. Bottoms up. 2x minus 1 equals 0. And now I can T-bone these and find my answers. Okay? My answers would be x would equal 3. That's what would make the left parenthesis 0. And x would equal 1/2. That would make the other parenthesis 0. Now, I need to represent this on a number line. Okay, I need to represent this on a number line. I am going to go ahead and draw a number line here. And I am going to put my 2 points, 3 and 1/2, on the number line. And I'm going to put dots here. Do I fill them in or do I leave them empty? Well, I look at my sign. That does not have a straight line underneath it. That means I do not fill in those dots. In fact, because there is not a straight line there, not only do I know that those dots or holes will remain empty, not filled in, I know when I do this in interval notation, I'm going to use parentheses because there's not a straight line there. Okay, that tells me both. All right. So now I got to see, well, where is my solution set? Is it in between those dots? Is it not? Is it opposite? What's going on here? I am going to take a value between these two. Yes, I could take 0. 0 is nice. I always like to pick a number between them. You don't always have to pick 0. I'm going to pick 1. 1 is definitely in between a half and 3. And I'm going to put a 1 in for all my x's. Bang, bang. And I'm going to see if this inequality is true. So I have negative 2 times 1 squared, all right, plus 7 times 1 minus 3. Is that greater than 0? Okay, well, this is negative 2 plus 7 minus 3. Is that greater than 0? If I combine these, okay, that is going to give me a value of 2. Is 2 greater than 0? Yes. Therefore, the 1 that I substituted in is in the solution set, which means I am going to include all the numbers in between those dots, okay, in my solution set. And when I write this in interval notation, I go from 1/2 to 3, but I do not include them, okay? There is no straight line underneath this. So I can't use the straight line, okay? I had to use the curved lines. There you go. And if you're looking to figure out what is the answer to this problem, the number line and the interval notation. It works like a charm every time. Let's look at C. Oh my goodness gracious. Oh boy, I cannot divide a number or a greatest common factor out of that at all. So again, I'm going with slip and slide because I love that. Now, if you want to get ahead of yourself, looking at this right here, there is no straight line underneath it, which means I'm going to use empty circles and I'm going to use parentheses. No straight lines. All right? So I'm going to slide the 5 out back and multiply my 12 times 5. I get x squared plus 28x minus 60 equals 0. And it is now a product sum. What multiplies a negative 60 and adds to positive 28. Factoring never goes away. Even after this class, you need to be good at factoring. I know two numbers that multiply to negative 60 that added 28. 30 times 2, positive 30 minus 2. Okay? I slipped the 5 out to the back with multiplication. So I'm going to slide the 5 back into the backs with division. X plus 6. And I cannot reduce this fraction, so bottoms up. 5x minus 2 equals 0. If I T-bone these and get solutions for them, x would equal negative 6, and x would equal 2/5. All right? Those are the numbers I'm putting on a number line. And the dots on that number line will be empty. So, my number line. Here's negative 6. Here's 2/5. And a number between them, nice, is 0. We already said this equation is not greater than or equal to, it's just greater than. So these are going to be empty holes. All right. Now I'm going to take that 0 and I am going to put it into the equation and see if it works. Okay. I'd like some space down here, but I'm going to erase some of this. I'm going to do this over here for the sake of space. Okay, I'm using this equation right here, and I'm going to plug a 0 I should say inequality. 5 times x, which is 0, squared, plus 28 times x, which is 0, minus 12 is greater than 0. These go to 0. So negative 12, is that greater than 0? No, it is not. So am I going to include my 0 in the solution set? No. So I am not going to include 0. I am going to go this way and this way. I'm going to avoid 0. Okay. Now, how do I write this as an inequality? Let's not forget, this side is negative infinity. It goes to the left forever, to negatives forever. This side is positive infinity. It goes to the right forever. So I'm going to represent both of those blue lines as they go to the ends with two separate interval notations. What do I mean? The left side goes from negative infinity to negative 6. Okay? Empty circle, so it's a parenthesis. With infinity, I never use parentheses. It's always, always, always a parenthesis. I'm sorry. With infinities, I never use a square bracket. It's always parentheses. All right? So, if you want to make that note for interval notation, okay, infinities, whether it's plus or minus, always have the parenthesis, okay? Now, I also have from 2/5 to positive infinity, parenthesis, and we say a union, so that's going to be a little u right there. It's a union, which means it's both of those. All right, there's my interval notation. And here, my friends, is my number line. Woo, a little bit of work. D, the last one. It's not set equal to 0. Oh my God, what do we do? Well, what if this was an equal sign? What would we do? We would set everything equal to 0, wouldn't we? So I'm going to bring my 5x, and I'm going to bring my 24 over to the left side. I could bring my x squared over to the right, but then my x squared is negative, and you know Visca likes to keep his x squared positive. I always like that positive outlook. So, subtract 5x, subtract 24. Subtract 5x, subtract 24. Bang, bang. I now have x squared minus 5x minus 24 is greater than or equal to, I now have nothing or 0 on the right-hand side. Well, this is a million times easier than the previous two we've done. We don't have to slip and slide or anything because now it's a product sum. What multiplies to 24? Negative 24. And adds to negative 5. Well, if I know anything about multiplication, and we all should at this point, in order to get a negative product, I need to multiply a positive times a negative. Now, in my mind, and you can write a little factor table with all the factors that multiply to 24. But in my mind, whenever I see the signs that are different, I think what adds to 24 that's different by 5. Now let me back up a second. When I see signs that are different, when I have a plus and a minus, okay? When I have a negative product, what multiplies to 24 that is different by 5? 8 and 3, okay? 8 is the negative number and 3 is the positive. The bigger number should take the middle sign because when I combine them, it should stay negative, okay? I should get negative 5 when I add them, okay? And now I solve this, okay? I solve this. And I say x should be negative 3 and x should be 8. There you go. All right, let's put those on the number line. Number line, number line. So fine. So I got negative 3 and I got 8. Okay. Are those going to be filled in or empty? I look here and there's a line underneath it, so it is filled in. Not only does a line underneath it tell me that the dots are filled in, that tells me I'm going to use square brackets for my interval notation. The $1 million question is, Am I going to have the solution be in between my -3 and 8, or is it going to point to the outside like problem C did? So let's find that out. Let's pick 0 again because 0 is awesome. And I'm going to put that into the original equation. Okay, I have x squared, so 0 squared was greater than or equal to 5 times x, which is 0, plus 24. Goes bye-bye, goes bye-bye. Is 0 greater than or equal to 24? No, it is not. So do I include 0? No. So my answer is actually going to go away, which is good because now we get to practice writing our interval notation with 2 interval notations. Okay? Again, goes to negative infinity this way. To the right goes all the way to positive infinity. So I go from negative infinity to -3. Infinity always uses the parenthesis, but for the -3, I want to include that. And I union, or I include, from 8 to positive infinity. Infinity always uses the parenthesis. The 8 has a filled in circle. Bam. And there you go. That's really not horrible at all. They want the interval notation and the number line. So we gave them the number line, and we gave them the interval notation. We give them everything they want because we're good at what we do. Take it easy. I'll see you on here, I believe, for Unit 1, Lesson 14. Hopefully. It's cool. It's cool hanging out with you. Hopefully you come back. See ya.